Everyone, welcome back to polars. Today we are going to talk about converting our polar coordinates to rectangular coordinates. So when we are given our polar coordinates, r comma theta, we want to convert them sometimes back into our traditional x comma y form. And the way we are going to do that is using r times the cosine of theta to get our x coordinate, and then our r value times the sine of theta to get our y coordinate. So if we have some exact values, think unit circle values, I'm given an r value of 4, a theta value of pi over 3. So to find x, I'm going to take 4 times the cosine of pi over 3. And to find y, I'm going to take 4 times the sine of pi over 3. So if you think unit circle values, the cosine of pi over 3 is positive 1/2. So that's going to give us 2. The sine of pi over 3 is square root of 3 over 2. Which is going to reduce to be 2 square root 3. So our final coordinate would be at 2 comma 2 square root 3. So that would be going right to up 2 square root 3, kind of a quadrant 1 value there. For our next one, we have an r value of -2, a theta value of 3 pi over 4. So again, we're going to kind of plug this in, r times the cosine of 3 pi over 4. And then we would have our y value, which is r times the sine of 3 pi over 4. Well, the cosine of 3 pi over 4 is negative square root of 2 over 2. So the negatives cancel, and then the 2 divided by 2 kind of cancels, and we're just left with square root 2. And for the y's, we have -2 times the sine of 3 pi over 4, which is square root of 2 over 2. That ends up being negative square root 2. So this time we're at right square root 2, down square root 2. So a quadrant 4 point. Last but not least, we have an example dealing with some degrees. So again, we have an r and we have a theta. So x is going to be r times the cosine of theta. And then y is going to be involving the sine of 210, our theta value. So our cosine at 210 is negative square root of 3 over 2. So that's going to end up reducing to be negative 3 root 3. And then 6 times the sine, which is negative 1/2, turns into negative 3. So this ends up being in quadrant 3. You go left, 3 square root 3, and down 3. Now some of these values, again, we are able to find using those exact x comma y values from the unit circle. Some of these we just have approximated values. So the first one is a radian value, so you want to be careful on that. You want to make sure, because we're approximating with our calculators, that our calculator is in fact in radians to handle this. And then we're going to just use our calculator to help us out, because we have r times the cosine of our theta value, which is 1.2, and then r times the sine, again, of that theta value, we get the x comma y. So again, you want to just make sure you are in the correct mode each time on this. So again, the x was about, I'm going to round to 2 decimal places, 1.81. Y is 5 times the sine of 1.2. So that's 4.66. And that would be our approximate coordinate. Now, if the next one, notice, is in degrees, I want to make sure I flip my calculator back to the correct mode. This time I want to be in degree mode. And again, I'm going to do my r value times the cosine of my angle, my r value times the sine of my angle. So 110. So I should be at 1.03-ish, comma, negative 2.82. And again, that's just found by taking r times the cosine of your angle, and then r times the sine of your angle, and using the correct mode to approximate. The last example then is going to be for you to try for number 6. Now, a couple reminders on this. Again, make sure, especially for this section right above, that your mode is important if you're in degrees or radians. Also understand, do they want you to provide the exact answer? So like section 1, where we're using the unit circle or the trig identities from that, or are you just approximating using your calculator? Think about, again, the sign conversions. Make sure that your quadrants, you're plugging those in as in if they're positive versus negative. And then finally, oops, this one should have been -3, side note. -3, which I typed in. And then last but not least, visual checks, kind of making sure that each of these coordinates actually makes sense with your given polar coordinate. They should be kind of in that same location. Thanks everyone for watching. We'll work more with these in class.